Hey gang, thought I'd do a little preview of our next topic, which is inverse functions and inverse relations. So first thing we're going to do is kind of plot just some ordered pairs. We'll just go point by point, and you can see I have a little grid here. -4, -1, of course, means, and we're just going to eyeball it. 4 to the left, down 1. There's -4, -1. Right, and then -2, 0 would be about right there. -2, 0. We're going to connect those. 1, 2 is 1 to the right, 2 up. We're just going to estimate it. We'll connect those guys. 3, -4 is 3 to the right, down 4. That's about there. We'll connect those with a line. Obviously, if you have a straight edge, that would work better. And then finally, 5, 1 would be right there, 5, 1. And I'm just putting the ordered pairs real small here into the diagram. Okay, so now we want to find the inverse. I'm going to color code this to make our lives easy. I'll do this in green. So the symbol for the inverse is that little -1 power. Okay, it really doesn't have anything to do with exponents. It's just it's what we used. We just picked that symbol for inverse, and it's as easy as you would think. We're just going to flip-flop the x's and the y's. So at its simplest, all you're doing is taking your x's and replacing them with the y's, and the y's get replaced with the x's. You can see I already messed up. 1, 2 would become 2, 1, and 3, -4 would become -4, 3, and finally 5, 1 would become 1, 5. Put it in the bracket. And then we're going to plot these and see what happens. So -4, -1 would become -1, -4. That's down here, right? And 0, -2 would be what, right about here, I guess. Right, we'll connect those. Next is 2, 1. Right, 2, 1 would be, I don't know, like right about here, maybe. 2 over, 1 up. Connect those guys. And then finally, -4, 3 is 4 to the left, up 3. I'm going to eyeball it and say it's about there. Right, so this guy will come over here. And then finally, what's left is 1, 5. So if I go 1 to the right and up 5, that should be about there. So even though you didn't have grid lines, I think this is definitely doable. Now, the one thing I want you to notice is that there is some symmetry between the green and the blue. It's not really symmetric in either of the axes, though. One of the prevailing things you're going to see is that this thing is symmetric in the line y = x. I'm going to do my best to kind of draw this, make it, yeah, that looks pretty good. So y = x is that line that cuts through the origin at a perfect 45-degree angle as you go from lower left to upper right. So it's the origin, it hits 1, 1, 2, 2, 3, 3. And you'll notice that, inverses, here's something you notice, inverses are symmetric. Actually, I should probably put this right down here in this little box. I have a box like all ready for this. Just move it down here. Inverses are symmetric in the line y = x. So that's just kind of a little introduction. So what are the big takeaways? Plot your points to your original function or your original relation, and then you just flip-flop the x's and the y's and plot those. And graphically, there'll be symmetry, but it'll be symmetric in the line y = x, that kind of diagonal line that goes from lower left to upper right. Okay, hopefully that video helped you out a little bit.